20 interesting facts about muscle contraction. 1. The architecture inside your muscles is such that they can only pull, not push on your bones, kind of like a car without reverse. 2. At the core of your muscle's architecture are two contractile proteins. One is called myosin that tugs or pulls on the other one called actin. 3. Myosin kind of looks like a round bristle brush, while actin looks like a thin string of twisted pearls. 4. The bristles or heads of myosin are separated into right and left halves, with the heads on each side in close proximity to opposing actin filaments. 5. When your muscles are stimulated, binding locations for the myosin heads are exposed on the actin filaments, kind of like seats becoming available for a sold-out Taylor Swift concert. 6. Once available, the myosin heads naturally extend towards and attach to the actin binding sites, forming a cross bridge between the two proteins. 7. Once a cross bridge is formed, the myosin heads swivel or pivot inward, pulling the actin filaments to the center and towards each other. 8. This process causes the muscle to begin to shorten and pull on the bone at the end of its insertion, kind of like putting a car into drive. 9. But wait, full contraction and complete movement requires this process to repeat over and over, which requires a constant source of energy for the myosin heads to keep on keeping on. 10. Myosin heads naturally attract ATP, the body's common energy source, which gets broken down to ADP and phosphate by the enzyme myosin ATPase, which has a fast and a slow version. 11. The fast version of myosin ATPase is found on type 1 or fast twitch fibers, while the slow version is found on type 2 or slow twitch fibers. 12. Fast twitch fibers also have myosin heads that pivot faster than those found in slow twitch fibers. 13. Therefore, fast twitch fibers, like the majority of those found in your gastrocnemius muscle, are built for speed and power, but they fatigue kind of quickly. 14. Slow twitch fibers like those in the other calf muscle, the soleus, are less powerful, but they have great endurance and extra mitochondria. 15. It's the aerobic systems inside the mitochondria and the anaerobic systems outside the mitochondria that supply all the ATP. 16. Once myosin uses the energy from the ATP, the remaining ADP and phosphate are removed, and a new ATP finds its way to the myosin head. 17. The new ATP causes the myosin to release from the actin, but in conditions where ATP is unavailable, like death, the myosin head remains attached to actin, causing rigor mortis. 18. The newly arrived ATP is broken down by myosin ATPase, and the energy is put into the myosin head, so when it reattaches to an actin, it will swivel immediately to continue the contraction process. 19. Once the stimulation to the muscle stops, the binding locations on the actin filament get covered up, preventing the myosin heads from binding and swiveling, so the muscle relaxes or goes into neutral. 20. But there's no design inside your muscle that allows them to reverse course and push on a bone that's just pulled on during contraction. Thanks for watching, and leave any questions in the comment section. And for more information, watch my other muscle videos in my YouTube channel playlists. As always, my answers come from peer-reviewed research.